I'm fine, Sanjeev. Fine, ma. So good morning to all of you. So now we will move to the further. Yes, ma. Raki, good morning. Good morning to everybody. Yeah. So Irfan, good. Shweta, yes, ma. Vineet, huh? Okay. So let us, Gupta, right, ma. Good morning, Gupta. So now we will start the session now. So now, yes, ma. Trinad, good morning. So Brahmani, good morning, ma. So to one and all, good morning. Let us start the topic now. So we will come to the topic. So here, the topic in today's class is, which is going to continue, that is multi-threading in Python. Well, so there, what we are going to discuss, it's very important and very interesting also, and a little bit complex, and I try to understand that. Okay, right. What we are going to discuss here, index. What first we are talking about? First point is, what is the purpose of multi-threading? First point is that. Next we are talking about another concept we are talking about. That is, next we are entering into purpose of multi-threading. Next I am talking about definition of thread. Next we are talking about types of applications. There we are talking about types of applications. There we are talking about first one, process-based applications. Well, and the next is called, second one is thread-based applications. Process-based applications, and next is called thread-based applications. Well, next we are talking about we are supposed to enter into thread-based applications, two types of applications. I will explain what are those. Next we are talking about module name required for multi-threading. That is a module name for multi-threading is threading. Module name is threading. One module is called threading, right? And the next number of approaches for developing thread-based applications. And there we are starting with programming examples. Well, and next, this is called one level of examples. There we are talking about locking concept, that is deadlocks concept. Deadlocks elimination concept. Right? Elimination concept. Fine. How we eliminate the deadlocks concept. Next, we are talking about module name. That is called module name for deadlock elimination, and the module name for the deadlock elimination, and what is the class for it. So here in threading, we use a class called thread there, and the module name required for there also I will write it. Module name required for deadlocks. Right? Deadlocks. There I am going to take threading. I'll take lock. Class name is called lock. Well, and next started with programming examples. This is the topic we are going to discuss. These are the topics we are going to discuss. This is the index of multi-threading. So let us start, students. What is the purpose of multi-threading and how these types of applications are coming? All these things I want to discuss. Easy. Now I'm going to start the introduction to multi-threading. So by this time, we must understand, in this class, we must understand what is the need of multi-thread-based applications, what are the advantages compared to the process-based applications. Yeah. So dear students, I'm going to give you one small example for you. One small example. Let us take it as one paint here. I'm taking a small example for you. Yeah. This is my small situation I'm giving to you. You try to understand very easily. Here, this is my OS. For example, my OS is available here. This is my OS. I'm having operating system here. So I'm having operating system now. Here I'm having operating system. Well, so here operating system, what I'm going to give is operating system. Well, see students, this operating system is providing the services to multiple applications which I'm opening. You know that. Even in our mobiles also, you see, this is the application of, I open one media player. I opened one media player. See carefully. A media player is open. This is called one media player. Next, I opened one more kind of thing, that is called one more thing I am opened, that is called what you know. An Edit Plus software is open. Next, I opened one Python software is open. One Python software is open. One Python software is open. Well, next I opened one more type of one server is open. Next is called one more type of database is open. Next I opened one paint also open. Next also I opened it, some Java kind of software is open. So here I am writing, paint application is open. Next is called Java application is open. Next I am opening one media player is open. Media player is open. So carefully understand. Well, and next I opened here Python program is going on. And next it is going on here, one server software is open. One database software is open. Database software is open. And one Django kind of application is open. Now, is your operating system is providing the service for one application or providing the services to multiple softwares? Is it providing the services to one software or multiple softwares? I need to know quickly. So our operating system is providing the services to multiple applications, because already you know operating system acts as an interface between multiple your application and the hardware. So our operating system is providing services to multiple applications. This is the best example of multi-threading. All the modern applications, all the modern mobile applications, all the modern operating systems are providing services parallelly to multiple applications. Here I'm going to understand here the operating system provides services to multiple provides the services to, I'm going to give you the clarity on this, provide the services to multiple applications. How it is providing? Parallelly it is providing, or providing simultaneously it is providing, or what? Concurrently means what? not even single minute gap, not even single second gap, concurrent, simultaneously or parallelly, the services are provided. Here, the operating system provides services to multiple applications parallelly or simultaneously or concurrently, and such a type of and such a type of execution, such a type of execution is called concurrent execution. We can call concurrent execution. We can call right. Moreover, this is the main point I just mentioned here. The way operating system is providing the service to the database, the way which is providing the service to the database is called one thread. Is called one thread. Carefully understand. Is called one thread. I am naming it. The way the services are provided to the server is called the thread. The way it is providing the services to Python software is called one type of thread. Is called one type of thread. I'm just mentioning it. Is called one type of thread. Same thing. I'm writing thread. Here also I'm writing the thing called what? Thread. Here also I'm writing something called what? Thread. Here also I'm writing something called what? Thread. So, if you understand, in the operating system, how many threads are there? All of you try to conclude it. Come on, ma. In the operating system, how many threads are there? 7 threads are there here. Seven threads are there. Hence, my operating system is called which type of application, which type of software? It is called multi-threaded operating system. Multi-threaded operating system. Come on, students, all of you type it. I would like to see that. I would like to see. Everybody must type it. It is called multi-threaded operating system. That means operating system spontaneously creates one thread. Spontaneously create one thread whenever a new software is created. I mean, my dear students, once again, I'm giving one more clarity. If I'm opening my Zoom, Zoom software, if I open it, immediately one more type of thread is created. This is called my Zoom. For conducting my class, operating system will create simultaneously one more type of thread. Now you can understand, my dear students, what is the thread and what is the purpose of thread. I must give you the knowledge here itself. What is the thread? I just want to give you. Definition of thread I want to give you. Definition of thread I just want to give. Actually, threading is, if you understand the actual thing, you can understand it. Fine. Right? What is the definition of thread? A thread is nothing but a flow of control. A flow of control. A flow of control. That means you look at carefully. Here I am saying a flow is created for executing this Zoom operation. A flow is created for executing this database. A flow is created for running this server. All these things are called what? One flow is created. One flow is created. One flow is created. So a thread is defined as a flow of control. Well, sir, what is the purpose of this flow? Purpose of thread I am going to say. Purpose of thread I am going to tell. What is the purpose of thread? What is the purpose of thread? I am going to give you. Purpose of thread. Very, very simple, students. Look at that. Purpose of thread is to execute, see students, to execute certain operation, to execute certain operation. To execute certain operation. Where do you write it? Where do you write it? The operations. Who will perform the operations? Come on, ma. Purushottam. Very good. Very good, ma. Excellent, ma. Rocky. Perfect. To perform certain operation, function is required. Function. To execute certain operation, whose logic is defined? See, ma. Whose logic is defined? Whose logic is defined in the form of functions. In the form of functions. Very well. You can understand most perfectly now. All of you must understand, students, to execute certain operation, the purpose of thread is to execute certain operation whose logic is defined in the form of what? Functions. In the form of functions, I am going to take. Very well. In the form of functions. Super. So what is the definition of thread? A flow of control is called what? Thread. A flow of control is called thread. What is the purpose of thread? The purpose of thread is to execute certain operation whose logic is defined in the form of functions. Very well. Now I'm asking a question. One more. A little flow. It's nothing but see, Rocky. I will give once again the knowledge for you. What is meant by flow? One more example I am going to give you. One more normal general example I would like to quote you. And you are my student sitting in the class. What are you doing by sitting in the class? You only tell me. You are called my program. Like an operating system, you are called my program. What are you doing by sitting in the class? Listening the class. Very good. Number one, that is super. Number one, listening. Number two is called what? Responding. Number two, responding. Number three, writing in the chart window. Number three is called what? Number four is called what? Number four is called what? You may eat something. Number five is called taking the breath, and you are going to observe it and you are going to executing the code simultaneously. These many operations you are doing in your brain. A brain is doing so many operations. See, students, Rocky, you asked me flow. These lines which I wrote is called flow. That means your brain is concentrating on multiple kind of activities. The way which you are chatting with me by typing in the chat box, the way which you are listening me simultaneously are called what? Flows. Are called flows. Am I correct? Rocky, did you catch me, my dear student? Yes, very well. So see, you are called what student you are? You are called your brain. This is called my Python program. This is called my Python program. It is called, in other words, my student. My student is called my student. My student is doing how many operations? Multiple operations simultaneously. Multiple operations simultaneously. So student is always working on multiple thoughts simultaneously. So if I put that type of multiple operations in a single Python program, my Python program is called multi-threaded program. As a teacher, what I am doing? As a teacher, what I am doing? I am teaching, I am typing, I am calling your names, and I am seeing your chat box. I am taking the breath, I am clicking the mouse, and I'm thinking how to teach the next lesson, how to teach the next sentence. So in my brain, how many flows are there? On how many things I'm concentrating? Multiple things I'm concentrating. So the way which I'm thinking, multiple concentrations are called multiple flows. Multiple flows are called multiple threads. Each thread is meant for performing certain operation. Am I clear? Am I clear about my sentences? Well, so coming to the things. Now, if somebody asks you tomorrow, why do you use multi-threading? What is our answer, my dear students? If somebody asks you multi-threading, what is the purpose of multi-threading? You have to say, sir, multi-threading is always used for achieving the concurrency. Achieving the concurrency. What do you mean by concurrency? Performing or executing multiple operations simultaneously. So far what we did, I will show you. Technical example also I will show you. Please look at, my dear students. One small example I would like to show. You see, in our Python environment so far, what we did, I am just going to show you. This is the default environment of our Python. Achieving the concurrency. Yes, Marenka. So this is called, so far what we discussed, I am writing. Default environment I am going to talk. Default environment of Python programming. So far what we did, I am going to show you, students. Well, here what is happening? And before that, what is happening here? I am having Some function I am having. My dear students, carefully understand. Some function I am having. Next, a sub function I am having. Next, a multiplication function I am having. Next, I am having div function I am having. Next, I am having something like modulus function I am having. Like that, I am having expo function, expo function, exponentiation function I am having. Well, whenever I start my Python program, tell me, my dear students, who is going to initiate? Who is going to initiate? Whenever I start my Python program, who will come into picture, my dear students? Whenever I start my Python program, very good, Ranjan, super. PVM will come into picture. PVM will come into picture. Well, super. I really appreciate you. PVM will come into picture. Well, student. The PVM, do you know, my dear students, this is an open secret which I'm saying today to you, which I'm revealing today. The PVM, this is called PVM. The PVM is doing what you know. Do you know, my dear student? I will write more clearly, because this diagram also very important for you. This is a PVM is taking into consideration. I'm writing here. See that what is happening. The PVM is coming into picture. I'm saying that PVM. I'm saying here PVM. And next, the PVM is having, everybody we will think so far, PVM only will execute this some sub like that. No, actually, now I'm going to say the open secret. Inside the PVM, my dear student, there exists one small thread. There exists one thread. See, my dear students, first time you are hearing this thing. There exists one thread. In PVM, who will execute the Python program? PVM will execute vset. But inside the PVM, there exists one thread, my dear student. There exists one thread. That thread name is called, there exists one thread whose name is called main thread we can call. What is that? Main thread. We can call it as a main thread. PVM by default contains what? Who will execute our program actually? PVM. Inside the PVM, who is there? One thread is there. And this is the ultimate professional will say. Actually, we feel that everybody, this is one of the most important sentences, student. Everybody will feel that PVM is like execute the program. It's nice. But I'm saying very, very micro level, nano level, if I go, in PVM, there exists one thread whose name is called main thread. So what is that main thread is doing? Main thread will execute this sum function. After sum function, it will come to sub function. After sub function, it will come to multiplication function. After multiplication function, it will come to div function. After div function, it will come to modulus function. After modulus function, it will come to what? Expo function. How it is coming? It will come one by one. It will come one by one. Right? Now I'm going to say how it is calling, my dear students. Everybody must understand in the class. The functions are calling. Seema, one by one I will write it. After this function is there. First it is going to this place. From there it is coming to this next place. From there it is coming to this place. It is executing the next. From there it is going to come to the next. It is going to execute this function. And from there it is going to come to the next. It will execute the next div function. From there it is coming to modulus. And modulus function will execute. And then modulus function will execute next expo function. Like that it will execute and gives the result. This is the flow how the program will execute. I hope that you people are understanding about what I'm trying to say. So tell me, PVM contains how many threads? How many threads PVM contains? Here, the main thread, only one thread. What is the name? Here, main thread of PVM Main thread of what? PVM executes the functions, sequentially. Is it executing one by one or all at once? Executing sequentially. Executing sequentially. Right? Fine. And it is considered as what? And it is considered as what? Well, considered as what? What based application? It is considered as what? Process based application. What is this? Process based application. Because these functions are executing sequentially. Sequentially means what? One after other. One after other. I'm writing, students. One after the other. This is the way it is getting executed. This is a way how it is getting executed. Sequentially, one after the other. And considered as what? Process based applications. Did you understand this diagram, students? Did you understand this diagram, students? Yes. Next, students, I would like to go for, yes, same environment, Python environment only. I'm going to the next part of it. Python environment only. Now carefully look at this part, you try to understand so that I can go to this. This is called programmatic environment of, that means programmatic environment of programmatic environment of Python. Programmatic environment of Python. Well, next I'm going to talk about what are my functions are available here. What are my functions are available here? Sum is one function. Sum is one function. Sub is one function. Sub is one function. Multiplication is one function. Multiplication is one function. Div is one function. Modulus is one function. Next, expo is one more function. Expo is one more function. Well, now here what is happening? What is happening? PVM is going to come as usual here. PVM is going to come as usual here. Well, PVM is going to come as usual. Now I'm writing here PVM. PVM. Well, now I'm going to write it. My dear students, carefully understand. The PVM will do what? And what you are doing programmatically. I will create a separate thread. I'm writing here. Carefully monitor I will create a separate thread for execution of this sum function. Separate thread. How to create a separate thread for execution of some thread? We are going to create programmatically a thread mechanism. I will create one more thread for sub. I'll create one more thread for this multiplication. I'll create one more thread for this division. I'll create one more thread for this modulus. I'll create one more thread for modulus. I'll create one more thread for expo. Now, these kind of threads are called subthreads we can call, or child threads we can call. These are all called what? These are all, I'm just trying to print one small diagrammatic explanation, student. These are all called what, subthreads or child threads. Subthreads or child threads. Who will create? A programmer can create. So understand, my dear students, these are called subthreads. I'm going to say subthreads. We can call it as subthreads. We can call. Well, all these subthreads are maintained by main thread, which was already there inside of where? I'm going to write it. These are all maintained by what? I'm going to write it. Which thread this is? Main thread we can call. This is called main thread. These are all maintained by what? Main thread. So it is nothing but a inside of this kind of thing. I'm just trying to write like this. I don't know how you will understand my diagram. Inside of this PVM, there is a main thread is available. So I'm going to write it main thread. So just I'm writing M thread. I'm just writing M thread. So here I'm writing. So T H I'm writing, M thread I am writing. Yeah, I'm writing here M thread. So R E A D. E A D. Right. A main thread is monitoring the subthreads, and subthreads are doing this work simultaneously. So did you understand this? These subthreads are created by the programmer by using which, that's what I'm saying, programmatic environment of this thing. So tell me ultimately, who will execute the functions? Who will execute my functions? Carefully answer, my dear students. Who will execute my functions internally? Yes, I'm waiting. Yeah. Who will execute my functions? No, ma. No. Yeah, Ranjan, very good. Subthreads will execute. Subthreads will execute. Who will monitor the subthreads? Who will monitor the subthreads internally? Main thread. Main thread. Simple, ma. You are there and your brother is there. Or you are there and your sister is there. Your parent is there. Listen my concept, ma. In a family, that means in your family, that is even in your Python program, your parent is there and two childs are there. Two children are there. Parent is telling to you, we have Sunday, two works are there outside, two functions are there outside. I cannot go to two functions at a time. First, I have to go to one function, I have to go to other function. It will take more time. He is saying, you please go to one function, one person, and one function, one more person go, he is saying. So what are you doing? You are attending two functions, one after the other, simultaneously you are attending. You are going to one function, your brother or sister is going to another function. What is that procedure is called? Concurrent attending or sequential attending? Concurrent attending or sequential attending? Concurrent attending we can call. Concurrent attending we can call. So if you are not going, your parent only attending first function and then second function is attending, it will take a lot of time. That is a sequential attending. So we don't want to go for sequential attending. Did you understand the subthread and main thread, my dear students? Did you understand the meaning of subthread and main thread? Very good, Mastavani. Good. All of you. Right. Sanjeev Kumar. Right. Very good. Fine. Now tell me, in a Python program, by default exist how many threads? By default exist how many threads? One thread is existing. This is the first question is coming. Now they will ask you, can you show me? Can you show me? Yes, sir, definitely we will show you. Definitely we will show you. Next, programmatically how many threads you can create? Programmatically how many threads you can create? I can create multiple threads. I can create multiple, many I can create. Programmatically, I can create many. And those many threads are monitored by which thread? Monitored by which thread? Main thread. Main thread is available inside of where? PVM. Inside of PVM. Now I am asking one small flow. All of you try to understand my question. What is that? Whenever my Python program will execute, who will be ready first? When my Python program starts executing, who will be ready? PVM is ready. Excellent. PVM will create what immediately? PVM will create what immediately? Main thread. Super. The main thread internally creates what? If you write multi-threading, the main thread internally create what? Subthreads. Super students, you got like anything. Subthreads. What subthreads will do? I'm asking what subthreads will do. I'm asking. Super. Execute the operations, perform the operation, which is written the logic inside of where? Functions. Which is written the logic inside of functions. Very good. Super students. Okay. How they are executing one after the other or concurrent? Renika, super. Concurrent execution. How they are executing? Concurrently they are executing. Who will finish the execution now? Who will finish the execution? No, careful. Subthread, Senapati. Very good. Subthreads will complete the execution. Subthread will finish the execution. Well, So if subthreads are finishing their execution, subthreads are nothing but after all variables. We are going to create a syntax, nothing but objects. Who will destroy immediately after finishing the execution? Who will finish? No, 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 no. Subthreads will finish the execution. Subthreads will be destroyed first. Subthreads will destroy. Finally, who will destroy? Finally, who will destroy? Main thread will destroy. Main thread will destroy. And PVM stops the execution. Did you understand the flow? Did you understand the flow? Yes, that is the flow. That is called thread life cycle also we can call. Thread life cycle also we can call. Well, now last and final. Who will execute the Python program? I am asking some questions. Please answer my question. Keep your hands on the keyboard. Who will execute your Python program? PVM. PVM creates what immediately? PVM creates immediately what? Excellent. Main thread, main thread, main thread. Main thread internally creates what? If I have multiple threads, subthreads will create. Subthreads will create. Super. What subthreads are meant for? What subthreads are meant for? Executing operations whose logic is defined inside of the functions. Excellent, ma. Excellent. Super students. Excellent. Who will finish the execution first? Who will finish the execution? Subthreads will finish the execution. Subthreads also called objects. Who will destroy now? Who will destroy now? Subthreads job is over. Subthreads will be finished. Subthreads are removed. Subthreads are removed. And who is left out? After subthreads are over, who is left out? Main thread is left out. Main thread is also called one thread. That also will be destroyed. That also will be destroyed. That time, PVM stops the program execution. Did you understand the students? Did you understand students? Well, super. Good. Now I am writing here. In this model of applications, in this model of applications, now I am writing in this model of applications, the PVM contains main thread. See, I am writing some small explanation. In this model of applications, PVM contains main thread, and it interns. I'm writing it interns creates. It interns creates subthreads. It interns creates subthreads. It interns creates subthreads, and they executes logic present in functions. Logic present in functions simultaneously or concurrently. And this type of application is called which based application, ma? Thread based application. I hope you are understanding. Thread based application. Now tell me, according to your knowledge, which applications will take less time, my dear students? Which applications will take less time? Yes, I must know that answer. Which applications will take less time? Yeah, I must know this, ma. Which applications will take less time? Thread-based applications will take less time. Who will take process-based will take less time? Thread-based will take less time. Thread-based will take less time. Process-based applications will contain more amount of time. Why more amount of time? Because a single thread only will execute all the operations. That's why process-based applications takes what time? More amount of time. Whereas thread-based applications will take less amount of time. That's why process-based applications are called heavyweight component. Heavy means what? More time is taking. And process-based thread-based applications are called a lightweight component. Lightweight component means what? Quickly they will execute. A lightweight person, a person who is having 70 kgs or 50 kgs, he will walk very fast. A person with 200 kgs will not walk properly. So heavyweight means what? One person only doing all the operations is called process-based heavyweight component. Oh, Sanjeev, correct. Less time is thread-based application. More time is taken by the process-based application. Anything is taking more time, they are called what? The process-based application. Anything is taking less time is called what? Thread-based applications we can call. Did you understand this meaning, my dear students? Did you understand, students? Right. My dear students, I'm opening one small description for you students. One small description I'm going to introduce. Let me introduce here one small explanation and try to understand this documentation. You see, my dear students, try to understand one small thing I'm going to say. In the context of OS, some small example I'm giving now. In the context of OS, we have a concept called multitasking. Just now I shown you the OS based concept, this one. So operating system is doing the multiple operations concurrently. In operating system, this concept is known as what? Multitasking we can call. Multitasking. Performing multiple tasks by the single operating system is called what? Multitasking. The main purpose of multi-threading in Python is that the multitasking concept only brought into the languages on the name of what? Multi-threading. The main importance of multitasking in OS is providing parallel services, concurrent services. The main purpose of multi-threading in Python is that to achieve concurrent execution. To achieve what execution? Concurrent execution. Nothing but what? Simultaneous or parallel execution. Well, multi-threading is one of the specialized form of multitasking of OS. In OS, we call it as a multitasking. In our languages, we call it as a multi-threading. Well, in this context, we have two types of applications. They are process-based applications and next is called thread-based applications. Well, student, what is a process-based applications? And you see, process-based application execution environment always contains how many threads? Always you have seen it, which I'm going to show practically also. How many threads? Single thread. Process-based applications provides which execution? Sequential execution. Process-based applications takes what time? More execution time, because one person only need to do everything. Process-based applications are treated as what? Heavyweight components. The best examples, all our C++, all our C++ are comes under what? Process-based applications. One example I am writing specially. One more I am writing. The default environment of the default execution environment of what? Python. Default environment of Python program. Python is also comes under process-based application. Is also comes under what? Process-based application. Process-based application. The default execution environment of Python is also comes under process-based application. Is also comes under process-based application. I hope you are understanding about what I am explaining. Did you understand, students? Did you understand this paragraph? Did you understand this introduction, students? Well, yes, ma. Senapati. Java is also containing multi-threading. .NET also containing multi-threading. Almost majority of the modern languages will contain multi-threading. So since we are in the Python, I'm going to discuss. Coming to the thread-based applications, my dear student. Thread-based applications execution environment always contains how many threads? Multiple threads performing multiple operations concurrently. Thread-based applications execution environment always contains multiple threads for performing multiple operations concurrently. By default, Python environment contains a single thread. That is a single-threaded process-based. Thread-based applications purely. That's why I gave two diagrams, ma. Two diagrams. Programmatic environment. Observe it, ma. Observe it. Programmatic environment. Programmatically, I am creating these threads. These threads. Well, coming to back. Thread-based applications provides concurrent execution. First of all, yeah, Renuka. One main thread, multiple subthreads. Super. So, thread-based applications takes less execution time because each thread is doing the operation, its own operation. If I have 10 operations, I will call my 10 friends who are helping me. So 10 people are doing simultaneously the job. If no friends are there, myself only has to do that work one by one. It takes a lot of time. Thread-based applications are treated as what? Lightweight components we can call. Lightweight components because executing very fast. The applications of Python, Java are comes under thread-based applications. Is it clear? Is by explanation is clear? Is it clear for thread-based application? Yes. Well, now I'm going to introduce and one more kind of thing, thread-based application I just want to show you. I want to show you a thread-based application importance once again. See, my dear students, we are entering into Python. How to develop thread-based applications. How to develop thread-based application. Now I'm going to give you. Look at, my dear students. Definition of a thread. Just now I told you already definition of a thread. See, all of you. A flow of control is called thread. A flow of control is called thread. Okay, sir. What is its purpose? What is the need of creating a thread? What is the need of creating a thread? What is the need of creating a thread? The purpose of creating a thread is to execute certain operation whose logic is defined in the form of functions. You know, students, functions are the heartful blocks in Python because they do the main operation. Such a type of operations are performed. Each function is executed by one thread. The purpose of a thread is that to execute any type of operation concurrently. Or the purpose of thread is that to perform the operations whose logic is written in the form of functions or methods. If it is an object-oriented programming, I will call it as a methods. I will use threads in whoops also, I will use it. Threads in whoops also, I can use it. Functional programming, I will explain. Object-oriented programming, I will explain for thread-based application. Nothing to worry. The purpose of thread is that, another way I am explaining, to perform the operations whose logic is written in the form of what? Functions or methods. Well, now, coming to students, is the definition is clear? Is the definition and the purpose is clear? Come on, ma, quickly make it. Is the purpose and definition is clear? Well, next I'm going to enter. You see, by default, how many threads are there in Python program? By default, how many threads are there in Python program? 1. Programmatically, how many threads are there in Python program? 2 threads. One is called main thread. Second is called subthreads. And subthreads can be many. 2 divisions I am taking. Well, students, see ma, whatever I said. When we write any Python program, there exist 2 types of threads. They are subthread or child thread or foreground thread. These are the names. And the main thread. Subthread or child thread or foreground thread are called what? Main thread. Well, sir, what is the purpose of subthread? The purpose of subthread or foreground thread is that to execute the operation whose logic is defined in the form of methods or functions. Whose logic is defined in the form of methods or functions. Written in the form of methods or functions. This is the importance of functions or methods. Subthread purpose is to execute the operations concurrently whose written in the form of methods or functions. Sir, what is the purpose of? The purpose of main thread is that to monitor the execution status of subthreads. Main thread is nothing but a leader in the program, which is monitoring the execution status of subthreads. Very well. Monitoring the execution status of subthreads. Monitoring which one? Main thread. A parent in the home monitoring you. You are a subthread. You are the person you are doing the original operation, whose logic is defined inside the function. So as I said, the general example, your parent said that go and attend 2 functions by two children. So whether you gone or not, he will verify in the background by sitting in the home. He is monitoring your status. Well, by default, we have a single main thread only. Programmatically, there is a possibility of creating multiple threads and recommended to have single main thread. Right? There is a possibility of creating multiple subthreads and recommended to have a single main thread, and main thread will be only one, and to have single thread. Did you understand these points, ma? Did you understand these 2 points? Right. Now it is a time to see a small example. I would like to write it. A small example. Sir, you said PVM contains one thread, na? PVM contains one thread, you said, na? Please show me that thread, sir. Can I show you that? Can I show you the execution, my dear students? Yes. Now I'm going to show you that execution part. How many number of approaches are there to execute the thread-based applications? We are going to see. Now we are going to enter into the small example. What is the main thread, sir? How the main thread is helping you, sir? That I just want to go for discussing it. Yeah, what, ma? Brahmani? Put a question mark, ma. What is your doubt, ma? Brahmani, what is your doubt? So you put a question mark. So I want to know whether you have doubt or understand about that. So I'm going to show you a single program about main thread information. Shall I go to the program now? Shall I go to the program now? Yes, students. Response is not coming. Yeah. Let's go to the first program here. Others. And say Python here. Python here. Right. So I'm going to take it threaded demo 1.py. Yeah. Now I'm going to take it, students, observe it. Now I'm writing print, hello, multi-threading program. Yeah. Now I'm starting print first class of multi-threading. First class of what? Multi-threading. Well, and this is a statement like that. I wrote it. Yes, ma Brahmani, in PVM by default, do we have a thread? That only I'm saying, nama Brahmani, in PVM, your doubt is this one, which was already there, nama, which was already addressed, na? Sir, in PVM, by default, do we have a thread? Yes, ma. See, here we are having, you see, ma, in PVM, we have a thread. Already, it is there. This thread will execute my functions one by one by default. Okay, ma Brahmani? Did you understand, Brahmani? Okay. So already it is there. Already I mentioned it very, very long back. Yeah. Now I want to go for this program I want to show. So who will execute the statements? Ultimately, you tell me who will execute the statement. I'm asking the final professional sentence. Sanjay Kumar. Careful, ma. Careful. Don't be hurry. Main thread, Rocky. Very good. Main thread will execute. Main thread. No doubt in that. Gupta. Main thread will execute. No doubt in that. PVM only will execute. But we came to detailed discussion, na? Detailed discussion. Okay. Now see, program, printer, program execution started. Sir, you show me that so that we can understand. Program execution started. Now I'm writing program execution ended. Program execution ended. Execution ended. Now I am writing here ended. Now here, these statements are executed by one main thread. Sir, how do you get that main thread, sir? We are having import to deal with the multi-threading. There is one module is there called threading. This is I'm showing how this is executing, right? PVM will instruct the main thread to execute the statements. PVM only will be there, but PVM is instructing its thread to execute that statement. Sir, how to print, sir? T name, that to default T name, df name, default thread name is equal to, there is one function is there, ma. What is that function? Current underscore thread. Current underscore thread, it is a function name. What is the current thread in the program? I am writing threading dot current thread. Threading is called a module name. Module name dot instance method. Module name dot instance method. It is called a class name. Threading is called one module name. Dot function name. That will give you. And don't worry about it. Just a name I will write it. Don't worry about it. I will explain that. So the current thread will come whose name I want to get it. That is placed into df name. I will print name of the thread. Default name of the thread. Default name of the thread. Default. Even if you don't print also, internally it is available. Default name of thread. Default name of thread is equal to dot format of df name, dft name, default thread name. I'm just writing like this. Just to see, my dear students, print off. Okay. And anyhow, I'm going to print it. Let us watch this statement now. I will create it. Save this code. I'm going to say in this place, I'm going to coming to this line. I'll create one folder. I'm saying that KVR Python 4 p.m. I'm going to say 4 p.m. So KVR Python 4 p.m. is created. Inside of it, okay, already it is there. Okay, already it is there. Or just create Python 4 p.m. So anyhow, it is only for Sunday, na? I will take Python 4 p.m. I am writing. Just 4 p.m. I'll just save my code. I'm just saving my code. What is my code name? Thread demo 1. Thread demo 1. Thread demo 1.py. Thread demo 1.py. Well, coming to the command prompt, something like, I hope G colon, something. In this place in my system, G colon. So Python 4 p.m. In that I have my program name. What is my program name? Thread demo 1.py. Say that py. Thread demo 1.py. See that now? Answer you see. The default name of thread is equal to main thread. See carefully, main thread. And this is getting, these lines are executed by only one and only one thread. Did you understand this discussion, students? Did you understand this discussion, my dear students? Well, now I'm going to say one more kind of small example. What is that another example? Look at, my dear students. One more example I would like to show you. What is it? Look at. Here I am having one more small logic. I'm going to write it. DEF. I'm saying that one function I'm going to say. What is that? Hello function I'm saying. Hello function. I'm printing small example, very chota example. So I am from hello function. I will write hello function executed. I'm writing in this place, this function. I'm writing hello function executed by. I'm writing here dot format of df name. I'm just going to write DFT name, default thread name. So how do you get it, sir? I'm going to show you that mechanism. Yeah. So for a minute, you just don't worry. This statement also don't worry. Next, I'm writing one more kind of statement, one more kind of function I'm writing. What I'm writing here, hi. I'm writing hi. So I'm writing I am from hi function. Hi function. Yeah. Now I'm writing one more function I'm writing. What is the function I'm writing? Show function I'm writing. I am from show function. I am from show function I'm writing. Show. Fine. Now you see my statements here. Hello executed by this one and allow hello executed. Coming to main program here, I'm writing there. Now be careful, my dear students. I will bring my statement what I written. I will bring this name. I'll bring this name. These are the statements in main program. Be careful, all of you. See, default name of the thread in main program. Observe it. What type of programming execution this is? In main program, I am writing. Well, I am writing this place. I am calling this function, hello function. Hello function I am calling. Next, a hi function I am calling. And next is called what? A show function I am calling. Show function. Start the flow. And your PVM started from here. It is coming here only, but it will not execute because no function call. It is going to start execution from this place. DF name, and it is printed. Thread name, default thread name printed. Hello. Who will execute this hello? All of you tell me. Who will execute this hello? I need to know the answer, please. Everybody must answer my question. Who will execute? Excellent. Main thread. Super students. Very good. You are understanding my explanation today. Hello. It will go to hello. Who will go to this place? Hello. Main thread will go and it will execute. It will come all the way to main program once again. Hi. Hi will go to once again to main thread will go to this place. Hi. Execute this logic. Again coming to main program. Show. Show will go to where again? Show will execute. So who will go 3 times to these functions? Who will execute 3 times? Main thread. Sir, write that logic once again, sir. Write that logic once again, sir. Which logic I have to write it? This only you write it. No need to use the DF name only. You use whatever you like it. You say T name only, you write it. T name only, you write it. Otherwise, you will feel that DF name means main program variable. You write the same thing here also. T name 1, you write it. T name 1, you write it. T name 1, you are writing. I am writing here T name 2. T name 2, I am writing. Here you write a T name 2. T name 2, you write it. Yes. Here I am writing one more time is called a T name. Here I am writing here. Saying here. T name 3, I am saying T name 3. It is called a T name 3. Well, T name 1, T name 2, etc. Be careful, my dear students. \n. Here \n. Here \n. Well, come on to the point now. Import threading. Yes, ma. Import threading. Super. Import threading. I'm saying import threading. Import threading. Well. Now this is called, I'm saying that this is called thread demo 2.py. I'm saying that how this is thread demo 2.py. Save this code here, ma. Save this code. Line number 13, ma. What happens? 13 or 12. What is happening? Okay. This is called show. Yeah. Show function. Okay. Now, show function. This is called a hi function. Yeah. I will write hi function. This is hello. This is called a show function. So show function. T name 3. Okay. T name 3. Well, ma. Well. T name 3. Did you understand? T name 2 and T name. All of them are same names only. You will see this now. Execute this code. Now I'm going to save this code. Coming to this place. py. See this now. Which is default name of the thread in main program is this main thread. Hello executed by main thread. I am from hello. Hi executed by main thread, I am from hi. Show executed by main thread, I am from show. What is your opinion, students? What is your opinion, students? Did you understand that? Did you understand that these are executing one by one or all at once? One by one or all at once? One by one. It is known as what? It is known as what? Which execution? Which execution? Sequential execution. Purely process-based application. Very nice. Very, very nice. Now I am going to give you the clarity on, okay, sir, we understand this mechanism, sir. Now show me the difference between what is an advantage of thread-based applications, sir. What is an advantage of thread-based applications, sir? Please show me the one execution process, sir. Now I am going to show you. Okay, right. Now I am going to show you all of a sudden what is the advantage of multi-threading. I already told you, but programmatically I should show you that. Yes, sir. Look at that. I'm going to give you one more example, my dear students. Please look into that. Import, of course, I'm writing thread demo 3.py. It's called a purely process-based because of sequential execution and concurrent execution. Yeah. I will take, my dear students, def. I'm taking one function, squares function, which is taking one list. Just a pass. One more function I will take it, def. I'm taking cubes of what I'm taking, LST, and a pass. Just I'm showing you. Just I'm showing you that. Now carefully observe it. Here I'm going to give you main program I am writing. Main program I am writing. Observe it. Observe it. This is two functions are there. One function will do squares, one functions will do cube. So I'm taking LST is equal to, I'm having some 2 comma 8 comma minus 4 comma 6 comma some 9 comma 12 comma some 67 comma some something like 25. This is my data. Okay, and I would like to execute this square function. I'm calling square normal function, so normal only I'm saying LST cubes of LST, squares of LST, 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 cubes of LST. Well, who is executing this also I want to mention it. Please be careful, ma. I will write it down. I will write it down. This thing I will take it. Observe it, ma. Default name. And here it goes to the pass. I'm going to give you the clarity on that area. This I'm going to give you this only printing process I'm taking. Now see that I'm giving the clarity on this area. Yeah, well, yes, sir. Now I'm going to give you executed by which function this is? Squares. Squares executed by tname1. What is my logic here? I'm asking. What is the logic? For value in LST, for value in LST, print of square of like this is equal to dot format of what is it? Val comma val star 2, val star 2. Did you understand? Well, now I'm writing, my dear students, I will make to execute with some gap of time, 1 second of time I want to display the numbers after 1 gap of time. Sleep of 1. I should say import time. You already know the sleep function. We used in where? Modules. Did you remember, my dear students, this one? Yeah. Import threading also, ma. Import threading also. Yeah. Now I will take the same thing. I will write here also. Careful, ma. Thread name 2, I am writing. Cubes I am writing here. Cubes, I am writing cubes. Cubes I am writing. Val, comma, value, star, star 3. Well, sleep, dot, etc. Now see that this is called what? No thread is available. These two functions are executed by how many threads? These two threads are executed. Those two functions are executed by how many threads? Quickly. One only. Senapati. How it is, ma? How it is by default? It is executed only one thread. So I'm measuring execution time here. I'm measuring execution time. So I need to show you the difference or not? I need to show you the difference in execution time or not? Come on, students. Yes, I will show you here. I'm recording the timing. Beginning time is equal to time dot time. Time dot time. It will take time is a function. Time is a module. And a time off is a function name. It will take including seconds also, microseconds also, nanoseconds also. Ending time also I will take it. Time dot time. Time dot time off. Now I'm printing execution time of this program. Execution time of non-thread application. Non-threading application. Non-threading application. No more threads are created by you. No more threads are executed. Shravani, already imported, ma. Already imported. So no threads are created by myself. So non-threading application is equal to dot format of what is the formula? ET, ending time minus BT. Ending time minus BT. Am I correct? Am I correct? Are you following, ma? Did you understand this? Fine. How it is going now? It is entering inside and then squares, and the main thread will go to squares, and then after that coming back again cubes, again go to cubes, and I'm measuring the execution time. Beginning I'm recording, ending I'm recording, I'm printing like this. Right, beginning time, Rocky, beginning time, before the main program starts. Starting time, I mean to say, starting time. Did you understand that? Beginning time. When I'm going to start my class, for example, I'm a thread, I'm a faculty. I started my class at 7:10. I will end my class at certain. I want to find the difference of the time. Right. That also will consider, ma. That also will consider. Format of, that only I'm saying, ma. ET minus BT I am talking about. Ending time minus beginning time. Ending time is more now. Rocky, ending time is more now. I'm talking that. I'm printing the difference of the time. Fine. Execute it. Execute this program once and see that what is the execution process. Very, very easy, students. PY. See, my dear students, see the fun of these answers. Square function executed. Main thread is executing. Square thread also executed by main thread. See, squares thread main, of course, so that I need to change the logic. Cubes I need to change. Cubes is printed now. See that execution time 16.17, 16 seconds, 17 milliseconds has taken it. Once again, I will just go for what? Here, cubes function this is. Cubes function this is. Execute once again, my dear students. So I'm saying taking that first squares function is coming. Result is coming like that. Fine. After that, it is going to execute this. Who is executing these two functions? Main thread only executing. See the difference of that 16.17. So two functions are executed by main thread. This function also executed by main thread. That's why it is taking this much amount of time. Right. Yeah. Purushottam. Next program I will show you, my dear students. Next program. Same program I am taking. See, my dear students, one very good result I am going to show. Please enjoy that and conclude that. Yes, ma, Sanjay Kumar. Very nice. Look at ma, look at. Now you see this program, how beautiful code it is. Now thread demo 4. Purely I am creating thread. Sir, how to create a thread, sir? So I am allocating square function will be executed by Sanjay, and then cubes function executed by somebody else, this is executed by some other kind of student called what? Ranjan will execute this. Ranjan will execute, and I'm calling my two students to call these two functions. Earlier, what I did in the previous program, myself only executed these two functions. Myself only executed these two functions, because myself executing two means after executing one function, I'm executing another function. But here, I'm going to call two threads today. Same beginning time, ending time, everything is okay. Now I'm going to create. After that, you see how beautiful statement I'm writing. And you don't worry about that. I'm just writing and I will explain. Next is that only. Today I'm showing you how threads are fast in nature, how threads are fast in software industry. All our mobile applications, all our internet is running on the thread-based technologies only. So Sanjay thread is equal to ST1 is equal to, don't worry ma, I'm writing one big sentence. Threading dot thread. Thread is a class of what? Threading. Thread is a class. I will explain this in detail in the next class. Thread is a class of what? Threading. Module is a collection of functions as well as what? Thread is a class inside of module. A module is a collection of functions, variables, and then classes of thread. ST1 is called one thread name, programmer defined thread. I'm calling. I'm telling to Sanjay thread this is. I'm telling to him, Sanjay, you please your target is an attribute. What is our target, my dear student? Square. SQ squares is my function. I'm targeting to him. Sanjay, ST1, you see, you are a thread. I'm creating a thread. Your target is what? Square. Target is called one type of what? Attribute. It is called one keyword arguments parameter. To the squares, I need to pass arcs is equal to. Arcs means what? I'm passing the parameter to that. Arguments I'm passing. What is that arguments, ma? LST1, comma you need to take. Comma, LST1. LST na, LST1 na? LST. I will explain this, ma. Renuka, thread is called predefined class, ma. Thread is called predefined class. Renuka, thread is called predefined class. Okay, Renuka, thread is called what, ma? Predefined class. Okay. What is the meaning of it? ST1 is called one thread, programmer defined thread. It is a subchild, it is called subchild. It is called a child thread. What is that child? Targeted to what? This one. Very good. And close this bracket. Take one more kind of thing. I'm going to say Anuj thread, or Rocky thread, or something. RT1 is equal to threading dot thread. What is that I should write? I forget. Yes, ma. Rocky, I said. It is taking in the form of tuple format. Tuple format it is taking. That's why comma is required. Tuple format. If you pass two values, you need not write a comma there. Okay, only one value you are passing, that's why you need to write a comma. Tuple format it is. Okay, what is this now? I should write it. I forget. Cubes. What is the target here? LST. What a beautiful. How many threads are created? That time it is not necessary. What should I write it now? This is called creating subthread. Creating child thread. Excellent. Who is creating child thread? Main thread. Because you are under the control of main thread. Main thread is created. Under the control of main thread. Okay, created. Send them, dispatch them, send them. You tell your child, go and execute square, go and execute child. For that, send child threads to execute functions, which is target functions. Execute the target function. For that, st1 dot start. There is a start. I will explain all these functions must start. Next time writing. Next I am writing RT1 dot start. RT1 dot start. Simple ma. You are ready. Your function. You are ready to go to square function. You are attending the function. Cubes function ready. Now you are going to say, I say, please go to function. I am saying start. Start is nothing but what? Sending your threads to where? These functions. What are you doing, ma? ST1 is going to where? Square function. RT1 is going to where? Cubes function. What I will do? What I am? I am the teacher of yours. I am monitoring you. In the line number 28, I must wait until you come back or not. I am executing which area? I am executing which area? Main program area. You are executing which area? He is executing square area. He is executing cubes area. Three people are doing three different operations. What is this operation mechanism is called? What is this operation mechanism is called? Come on, students. Concurrent execution. We can call it as which mechanism? Concurrent execution. Excellent. So I should wait at line number 28 only until you come back to me. Until you come back to me. I say ST1 dot. I am saying that join. I will explain join. RT1 dot join. I will wait there until you will join with me again back. I created you. I started you. Main thread will wait until you join. I will explain this join now. I will explain start. I will explain this syntax. Next class I will explain. Don't worry. And you can understand easily also because we learned big statements. Did you understand, ma? Did you understand this statement? This is called thread-based program. Did you understand this example? All of you. Ranjan, Rocky, Sagar, Senapati, Shravani, Pooja, Poonam, Gupta, all, one and all I am calling. Irfan, Brahmani, Neeraja, all of you. Renuka, all of you. Right. Simple, mom. See, I said you, go and do the shopping. Go and do the shopping. ST1 shopping, RT1 also shopping. I am waiting, sitting there until you come and join with me. Did you understand that? In this word, in this way, you understand that? Yes. You suppose you are there. You send your children to do the shopping, and you are not going because you are tired. You are waiting. You are waiting there until they join with you. After joining, you are measuring the time. Am I correct? After joining, you are measuring their time. Right now? Fine. Did you understand this joining, student? All of you? Did you understand this joining and starting and these two lines? These two lines are creating child threads. This is sending to them and I'm waiting them until you join. A beautiful example. Execution time of threading. See the beautiful flow. And see now, my dear students. No, ma, Arun Kumar. Not the moment when you join with me, Arun Kumar. Understand me, ma. The moment when you join with me, after finishing, you are joining with me. Obviously, once they finish and join with me, automatically they will be destroyed. Arun Kumar, did you understand, ma? Once you join with me, after completion of your execution, I don't need this ST1 and RT1. Automatically, they will be destroyed. Very good. Okay. So, main thread will not join, ma. Main thread is still at line number 28 and 29, waiting for ST1 and RT1 to join. Right? No, Irfan, start function is called what? Start function is nothing but a predefined function in the threading. Right, now I will execute this program and see. And here, what is this ST1, RT1 are called objects of threads, which are printed their names as what? You are printing. Who is coming to squares? ST1 is coming. What is the name printed? Internally, Python environment has given a name called thread1. Internally, Python environment has given a second name of the thread called thread2. Right? Yes, ma, Arun Kumar. That result will be shown on the monitor. That result, you will see that result. Understand. What is the default? What is the thread name of ST1 by default? What is the ST1 name by default? Thread 1. What is the name? Thread 2. Thread 2. They are giving. They are giving. Did you follow this discussion? Did you follow this discussion? This is the default. How to give my own name also I will give you. Right. Let me execute this code and all of you ready to understand this answer, please. Let example 4. See, my dear students, see the time of it. Earlier one, 16 point. Once again, I will show you the previous program. Previous program execution I am showing. Previous program execution, you see. Previous program execution, you observe it. Now see that 16.177, etc. Now you execute thread execution demo 4.py. See the logic. Name of the thread, please. Main thread. Squares executed by thread 1. SQR2. Cubes are executed by thread 2. This see this. Completely answers are coming. Less time is coming. How it is less time is coming? Because the main thread is not doing those works one by one. They are all done by what? All at once. Did you observe the execution time? Did you observe the execution time? Yes, Marenika, very good. Thank you. Did you observe the execution time? All of you should understand. See the result. Squares result is coming. Cubes result is coming. Everything is there. Right. Yeah, this is called what? Concurrently doing the work. You are doing your work. I am doing my work. So earlier time is called 16 point and this is called 8 point. That's why in the internet, when you log in into Gmail, I am getting my own services. When you join into Gmail, you are getting your own services. Now you are getting a full of clarity. I hope that with this execution, you got a full of clarity. Am I clear? Am I correct? First of all, am I correct? I think that you got a full of clarity. Every student, Shravani, yes, ma'am. Everybody, Ranjan, Renuka, everybody, I'm asking you, did you got the clarity on this execution? Very good. So, what is the thread names? By default, what are the thread names you have? Default thread name, main program, and C squares function, thread 1, and a square cubes function, thread 2. Thread 1 and thread 2 are called what? By default, child threads are having that name. If you want to give your own name, happy sir, I will give my own name like this. Please look at ma st1 dot name. st1 dot name. I will explain. I am saying that Rosam. Once we is a person is executing. st2 dot. What is that? rt1 dot. Okay. rt1 dot name. I am giving something like Ranjan. I am giving Ranjan. This is the names I am giving. I am giving the names. See that execution now. See that execution once again. And see that thread execution. See ma, squares executed by Rosam, cubes executed by Ranjan. And main thread is like this only. See my dear students, answer you see 8.017. I am giving the name to my threads. Rosam is 1, Ranjan is 1. These are called subthreads of your main thread. I have the complete clarity. So what is the clarity here? Whenever our Python program is started, PVM is created. This is called PVM. This is called PVM. PVM internally creates what? Main thread. Main thread internally having what? Rosam thread is there and Ranjan thread is there. They are doing their own operation parallelly. Parallel outputs are coming. Did you understand my discussion, students? Very good. So, which applications are fast? Which applications are fast, ma? Thread-based applications are fast. That's why our total internet world is running on where? Thread-based applications only. Our mobiles are running on thread-based technologies only. So, I hope today we understand. Yes, ma, Renuka, thank you, ma. So coming back to this example, you see this example which I gave you. Introduction to thread-based application. Thread-based applications are called what? Lightweight components, because half of the time only. And this process-based applications are what? Heavyweight components taking more time. And moreover, I said one more example, and see that the purpose of subthreads or child threads to execute operations written in the form of methods or functions. So I wrote square logic, I wrote cubes logic, executed by which thread? Subthreads. So what is the purpose of main thread? Which is executing the execution status of the subthreads. By default, there exists a single main thread. And programmatically, how many threads I created? Yes, ma'am, Senapati, we can do that. I will show you that result also. How many threads I have? 2 threads I created today. I may create 4 threads also. I may create many threads also. Many threads also. Yes, ma'am. Chakri, I can explain web scraping, ma, no problem. But it is a concept in data science, ma. Chakri, I can explain web scraping, no doubt in that. It is some algorithm I need to use it in the data science. Data science related, ma, Chakri. Otherwise, I would have been explaining, no problem. That is algorithm I have to explain. Algorithm implementation followed by data science related examples. It's easy. Web scraping, web harvesting, that is called that. Right, ma'am. So, Neeraja, any function to handle multiple threads? No, I did not get you, ma. I did not get you. I did not get your answer. I did not get your answer. Right. Kumar, what is the use of process-based threading? Process-based threading, no, ma. Process-based programming. I mean, that is olden days. That is the olden days. So what is that? Any function to handle multiple threads as parameters. No, ma. We are going for here. We are creating multiple threads by using thread class. Here the parameters are to which function to target to execute your subthread. Subthread you are targeting to execute squares, and you are passing the value to that. You are passing the value. And again another thread you are creating targeting to cubes, and you are passing some input. I will explain this once again in the class. That is the next day I will explain. I'll explain next day. Right. So yes, ma, Chakri. That's true, ma. That's true. Yeah. Thank you, ma. Thank you, Chakri. So class is class, ma. Class is class, because watching some videos, that is definitely not understanding. Definitely, ma, Chakri. You are giving very good complimenting message. Thank you. And your Chakri is saying this. Of course, he's saying that. So this kind of thing. Once we observe, understand, once we listen our class concept, na, you will get very good now. So, okay, yeah. So anyhow, I will stop my class, and it is 8 o'clock 44 minutes. I'll stop my class. I will post this program today itself. Yes, ma, Purushottam. Very good, ma. Thank you. Good morning. Yes, God bless you. So all of you, good day. I will post this tomorrow as usual, 4 p.m. Offline, online. We will continue from where we left today. We will continue it. Thank you, students. Good day. All the best. Yes, ma. Knox. Okay, super class students.